everybody for joining. We have Klint Skelly as well as a host of other folks from our Pueblo office going to present to us some fine information on hodographs. It's a skill of mine that has probably atrophied over the years, so I am looking forward to maybe refreshing some of those skills and learning a little bit more. So Klint, when you're ready, go ahead and take it away.
All right, hey, thank you. Yeah, my name is Klint Skelly, forecaster here in Pueblo, and I'm joined and very grateful to be joined by a whole bunch of people. On the left-hand side from NWS Pueblo, we've got Mike Garber, Paul Stewart, Mike Reiser, Cameron Simcoe, Stephen Rodriguez, and they're all great, and we all chipped in with this presentation. And then over on the SPC side, we're fortunate enough to collaborate and just work pretty intimately with Harry Weinman, and yeah, he brings a whole wealth of knowledge, especially the Hodograph section, as I'm sure many of you know. But our presentation is it's titled "When the Hodograph Bows." Welcome to the NWS Pueblo messaging show. Hopefully I was catchy enough to get a few more people on here to talk about messaging here in Pueblo, and culture and science and all of that together, because truly it's this event that happened on June 7th. There was a synthesis of culture, science, and service all together, and we'll get into the details about that. So just a brief intro on the day. We were expecting severe weather on that day. Scattered thunderstorms were expected to develop over the Palmer Divide, the Wet Mountains, the Raton Ridge area. These are areas that are prone to where our convection initiation is. Early in the day, with our forecasts, we're originally expecting splitting storms, supercells, with the primary risk or threat of large hail and severe winds. But as things happen, an outflow boundary that occurred overnight over Kansas, it really manipulated the lower levels over the far eastern plains. It turned these splitting supercells into more of a right-moving dominant kind of storm evolution, and that led to two right-moving supercells that produced some tornadoes. And here's some images that we gathered. So the top left one is from Steve Hodanish, a lead here in the office, of the supercell. He focused a little bit further north, but took a photo of that supercell from the north looking south. And then the LSRs from that day. And as you can see, we did essentially see the convection initiation over the mountains, Palmer Divide, Wet Mountains, and over the Raton Ridge with these LSRs of hail. But then, as you can see, a whole different story is being told as we get to the far eastern plains. There's a lot going to be talked about in this presentation. A lot of it, is, science, and we're going to talk about the synoptic setup, the mesoscale setup, and we're going to talk about, just the progress throughout the day. But, each of these images kind of highlight different initiatives that happened at NWS Pueblo, different mindsets and whatnot. So, the upper left is our be curious mindset. Of course, the upper go team, this obviously team building, the general office culture in our office. Weather ready nation's always a theme. Then we used, more national sorts of initiatives. It's like the Central Region Mesoanalysis chat room. We use that heavily during this event. And then the bottom right, this is, it's almost considered old school NWS Pueblo now, but for the past few years, we've been working on this Hill-C initiative, and we've presented on it here on the Central Region speaker series too, but high impact, low confidence events, and how to, how we message it through the use of core partner interviews, IWTs, stuff like that. But anyways, right in the center, that's what matters. It's the culmination of culture, science, and service. You can have, them single things by themselves, but if you put it all together, the end product is it's much better. So that's what we focus on at NWS Pueblo, is to bring all those three together to really, enhance the end product to our core partners and the general public. And, started off with any good, leadership kind of or culture-based presentation with a quote. Rome was not built in one day. And, this is a little less known about it, but this is the second part of the quote. And neither was the culture and the courage at the NWS Pueblo to try these types of agency-wide collaboration. And of course, that's a joke. And that's probably said by me because I wrote that down. But at any rate, servant leadership, it's a big theme at NWS Pueblo. I will, start from the top and work down, but, our management team, Ariel Cohen, Paul Wolin, and Greg Hevener, they've all been, servants in leading us at NWS Pueblo. Speaking just to highlight Ariel Cohen, our MIC, he's been in the trenches with us the last 2 years, and I'm sure everybody knows Ariel, and he's an incredible scientist, incredible meteorologist, especially in the mesoscale and the convective side. And he was working with every single person at NWS Pueblo to teach us what he knew. And I think that really goes a long way to have somebody who's there with you working these high-end convective events, or even any kind of event really, but having that kind of expertise be with you and be willing to share and open about it. That servant leadership does not really just stay in the ranks. However, it's everywhere. We go from management team empowering our leads, who empower our GS 5 through 12 journey forecasters. It's straight through it. And that servant leadership is a bunch of different things, in particular mentorship and being there with other people and teaching them what we know. But as an office in general, we have to be open to try these sorts of newer initiatives to see, to vet if it works or not. And in this case, when we're trying this whole agency essentially concept, I say whole agency because the people who are part of it will be outlined, but you have to be kind of open for that. Instead of being our island of a WFO, we opened up the borders a bit and allowed a lot of influence to come in this particular day. And yeah, we'll talk about that.
All right, thanks, Klint. This is Harry Weinman, by the way, at the Storm Prediction Center. I'm just going to kind of lay out the way that we handled the science side of this presentation. So I led the science team and worked with Mike Garber, Mike Reiser, and Paul Stewart. And we're going to, all three of us, go ahead and really essentially show how we started out with this background synoptic environment that was favorable for supercells, intense supercells, with large hail, severe wind, but not necessarily a very highly evident tornado setup, supercell tornado setup. We're going to show how, by paying attention to the details, working as a team, and really collaborating, staying curious about the environment, how it could change through the event, we're going to show how we could keep up with those changes, anticipate them before it happened, and we're going to show that integrated with how we message those changes at the same time. And this takes a lot of work, and just really being open to hearing everybody out on the team, and and also the challenges of really messaging a high impact but low confidence event and how you transition that message. So at this point, I'm going to pass this over to Mike Reiser to explain the synoptic setup.
Morning, everybody. As far as the synoptic setup is concerned, it started out, as you can see, westerly mid-level speed max to the north. It glanced our CWA. The mid-level flow, there was a 40 to 45 knot mid-level flow and a boosted deep layer shear. And there was some weak synoptic forcing due to minimal curvature and height. And zonal and downslope flow would support increasing lead dropping over Colorado plains throughout the day, and it was a bit weak. So what we were expecting out of this, when we were looking at it this way, we were expecting supercell development, the typical type that we would normally get, with the hail and everything else, but we weren't expecting any tornado genesis or a TBS or anything like that, not out of these. But as you'll see later, that we were a little bit wrong about that. So,
but let me jump in here, Mike, just for a second, because again, this speaks to, the idea of that we have all of these range of possibilities that it could occur. Did supercell tornadoes essentially, in the beginning of the event, did it look like the most likely outcome? No, it did not, but we never ruled it out. Right from the beginning, you'll see as we get through the messaging slides that it was never a solution that we ruled out. We always kept an open mind to it. And how could things change to make that outcome really become a reality? And so while it wasn't the most likely scenario, I think it's really important to recognize that it was never ruled out. It was always on the table. And we're going to show kind of how keeping really a close eye on the environment, we get ahead of that. So if you could go next slide there, Klint. So this is just taking a look a little earlier in the day at the surface pattern, just to kind of reiterate what Mike Reiser was saying here. Overall, we had a weak large-scale forcing over the area. You can see that in the low-level wind field. There's really not much in the way of low-level mass response, baroclinic gradients, nothing really too synoptically evident here. Just this kind of sporadic light winds. We do have good moisture, especially for this high in elevation over the eastern Colorado plains, and even better moisture with 60 dew points just to the east. And we're going to see how that is really going to affect the mesoscale environment later on by paying attention. What is happening with that moisture? What's happening with these mass fluxes through the day? But yes, so this just reiterates that weak large scale forcing overall. Next slide.
All right, and so this is what we talk about. There's going to be a pretty continuous theme here about the word continuous, and then how we message throughout the event and pretty much all of our events. But here's our morning weather story. So as kind of previously discussed, we were talking about the chance for severe weather. We were outlooked. We had a slight risk. And I mentioned it earlier. We're expecting convection to develop over the mountains, the topography, and move east into a little bit more favorable environment. We did have mention of all of our modes in there as well. If you look at the bottom right-hand corner of the weather story, hail up to baseball size, winds up to 70 miles an hour, and an isolated tornado possible. This was issued at 5:02 a.m. But of course, with all things weather story and being in this complex topographic environment that we're in, we were also expecting spotty near critical or critical fire weather conditions over our mountain valleys. That's what we had for our morning weather story. And I'll pass it along for a little bit more detailed discussion of the meso analysis in the morning.
Good morning. This is Michael Garber. I was in charge of the mesoscale analysis for the event, and I'll be chiming in a bit with some perspectives because me and Ariel were the warning radar operators for this event. So looking at the morning of June 7th, just sort of touching on a couple of things we said before. Like Klint mentioned, there is going to be a theme of a lot of continuous flow and evolution of information and messaging from all sides. So like Mike Reiser said, we had some pretty good deep layer shear over our CWA. Something to note though is that with that speed max overhead and these strong westerlies through most of the mid and upper atmospheres, this is really going to favor more long straight hodographs. There's a lot of speed shear, but pretty poor directional shear. And so long straight hodographs, as many of us know, would primarily favor splitting supercells and a hail wind risk. We had a really, lack of storm relative helicity. And so what we were looking at, kind of our expectations early on June 7th, as the morning shift came in that day, was large to very large hail, along with some pretty strong outflow wind gusts, which, while notable, we did have a slight convective outlook risk in our area, isn't without, it's well within realm of expectations for a severe day in this area. So, while we were coming in with a set of expectations, we're going forward, we're going to see how that be curious mindset really allows us to adapt to a pretty quick change in circumstances. Next slide, please.
Just 1 second there. I'll just throw one more thing in there, Mike. So yeah, excellent And that's exactly what we're looking at here. But just kind of to bring it back to the very start, that synoptic pattern, you know, with that weak forcing for ascent, we had an excuse right off the bat for this discrete mode, discrete, semi-discrete, supercell mode. And so while we did have that straight hodograph, which, as we do know, you know, doesn't necessarily favor quick mesocyclogenesis, with that maintenance of a discrete mode and this very favorable deep shear, we know that, you know, it's not out of the range of possibilities. So just wanted to throw that in there. Next slide.
And now kind of just looking at our early day thermodynamic profile in the elevated mixed layer we've had, you can see over our far eastern plains, we have some pretty good and really steep mid-level lapse rates, you know, so pretty good amounts of cape. We did have a little bit of inhibition, especially over our far southeast plains. That was caused by some overnight convection to our east in the Kansas area, which will play in a little bit later once we talk about the actual storm evolution post-convective initiation. But just talking about the morning, you know, we had that inhibition will serve to either maybe quash a little bit of afternoon evening convection or perhaps enhance it if that's able to bake in the sun for enough of the main day, really get that diurnal heating. We had plenty of moisture in the area. We had good mid-level lapse rates. So again, this is really just supporting our morning expectations of this is mainly going to be a high hail threat day, high wind threat day. You know, that really good directional shear, lots of mechanical mixing, really robust, potentially isolated, you know, organized updrafts, but like Harry said, not particularly conducive to mesoscale, you know, mesocyclone rotation. And so, you know, you can't just dismiss it just because it's not the most likely scenario. So going forward, we're going to take a look at how we message some of these probabilities and how we use this communication network that we've established around our CWA and beyond to sort of take this into account.
Yeah, and continuing on what Mikey said there, there are a couple infographics. Over the years, NWS Pueblo has been huge about these infographics. It just happened naturally. But at any rate, the upper left-hand one is one that has been brought up before, but it's our HILSI, High Impact Low Competence event that we started a few years ago. You know, this all kind of like evolves, you know, the recognition, communication, and then, you know, we were trying to support, you know, how to properly message with feedback from our core partners. That kind of led into our flash flood messaging paradigm. And, you know, this is something that's used for more than just flash flooding, but, you know, it's kind of like a ready, set, go setup. We talk about the days leading up to it. You can talk about the hours leading up to it. If flash flood is near imminent, or, you know, whatever hazard it is, because we kind of adopted this for everything. But, you know, the main point of it, though, is this continuous flow of information. And, you know, I thank our office quite a bit, because having this open mind, we've had a lot of these little initiatives that our office has been more than willing to test out for us. And we found some home runs there, I think, with our HILSI, our messaging strategy, and then all of that moving into this the right circular infographic of our be curious kind of mindset with our continuous flow of information. And, you know, reading the points, you know, continuous flow of information as you go around the circle there, you know, it's continuous information with even more and more, you know, specificity about what could happen that day. And we finally reach our messaging, a more complete array of potential impacts, you know, keyword with potential on that too. In this next slide, you know, we kind of show what that looks like. So, you know, same infographics on the left-hand side. On the right-hand side, this is from a previous talk that we had, but from May 2nd of 2021, days leading up to it, that top graphic right here, you know, just, it's kind of a broad brush, you know, it tells you what kind of potential impacts are going to have. You know, once we get to that morning weather story, that's when we, and the previous day's weather story, we're getting a little bit more specific with each time step in the future, right? Then going to the bottom left, in this graphic located here, we're talking more specific, but we're still kind of broad brushing, our locations. And in this case, we had a severe thunderstorm watch out issued by the SBC. But then, we continue that. We had the bridge between the watch and the warning, right? So now we continue to downscale the messaging and have higher confidence with our forecasts. And we'll let you know in our infographic, right? So in this top image on the bottom, the top image of the bottom image, I guess, we're talking about a little bit more broad area, but we're downscaling. We've got hail, we've got winds, and we have, most importantly, we're starting to have higher confidence. But then even going further, we can keep going, right? Like in this graphic on the bottom left-hand corner, now we're specifically talking about brief tornado spin-ups between 3:30 and 4:30 p.m. That's an hour window that we were expecting a tornado, and in this case it worked out. We had moderate to high confidence, and that ended up leading to in this case a tornado warning. Not all, I think, mesographics and events lead to this perfect outcome. Obviously, we're going to show you the most perfect outcome, but we're talking about a certainty with these mesographics as well. And so if there's a high impact, low confidence event and we still have low confidence on it, we're going to let people know about that. But all of this just kind of spun up from a whole bunch of different office initiatives, and these graphics weren't sent out by the people who say we're leading the initiatives. This was a whole office kind of concept leading to this event, and this goes directly back into this the office culture kind of conversation. We're practicing it in all different levels, and everybody's a part of this. So, anything to add, folks?
I'll just add something here, Klint. This is Harry again. Just to reiterate how crucial this really is, this event, this workflow, to really meet the needs that of our partners, of providing that IDSS at that level where people are making decisions. And at SPC we can't always get to that level of detail, so it really is critical for the local offices to be able to really build on this this way of really messaging and keeping a close eye on the environment, working with our partners, working with Storm Prediction Center, and downscaling that message to the county, to that really small scale decision makers point of view, because that's really how we're going to accomplish that mission there.
Yeah, and that brings up really good points, Harry. Not everybody, I guess different people need different points of lead time when it comes to these events. Like, say, for example, a hospital, they would probably need a little bit more lead time than 15 minutes if there's going to be a potential, like, say, a tornadic event over that area. So giving these kind of more broad brush kind of things, downscaling the continuous flow of information throughout this could potentially give say that hospital a bit more lead time than just having the warning out as well. So now going into our midday update from the June 7th event. On the right-hand side, we have two different mesographics. We split it up because there's quite a bit of timing difference between. So in the upper graphic, I believe the whats are about the same. The wheres, of course, are a bit different, but then the timing's a bit different as well. And so, we've got convection initiation from 2 to 5 p.m. over the eastern mountains, and then spreading from 5 to 9 p.m. over the southeastern plains. And then similarly, up in Teller, El Paso County, and then our northeastern plains, kind of saying the same thing, just different times. But kind of giving a testament about these graphics and about how the evolution of how they've I guess evolved, I suppose. But the previous graphics, we didn't have any of these gradients that we're talking about. So we're continuously trying to improve upon these graphics throughout time. And if you look at our graphics now, they don't even look like these necessarily anymore with the background. We have more of a topography base map on there. So we can really highlight our complex topography in our lower elevations. But at any rate, going back to these graphics, the midday update, we're still suggesting, supercellular, I guess convection, and then we still had that isolated tornado may be possible, but the confidence wasn't quite there. High impact, low confidence event again. But at this point, we're able to communicate more specifics on what might occur. We're beginning our downscaling of our impacts, and we're talking about confidence as well. So, anybody have anything to add?
Yeah, I'll jump in briefly here. Just behind the scenes, it's been really fascinating to see how these graphics have evolved, not just as Google Slides that we use as a tool of information, but also kind of the positive impact it's had on our office culture. Where at the beginning it was an experiment. It was, let's try this out, let's see if it works. There's a lot of learning involved for if you're not familiar with Google Slides software, how's the best way to send it out? And it's evolved over many, many months of just this constant use. And it's gotten to this wonderful point where this is just another quick draw tool in our arsenal to really inform our partners in public of what our thoughts and expectations are for really any given day. And now it's really gotten to this point where everyone's seen the merit of these in real time, and now we can crank out these fairly complex looking graphics in just a few short minutes. So it's a very powerful tool that can reach a lot of people very quickly, and we've really gotten some great positive feedback on that from the partners.
All right, thank you, Mikey.
And now jumping back in to some of the mesoscale analysis. So this is post-convective initiation. Obviously, you can see the GR analyst loop there on the left side. The event started off pretty well within our mean expectations based on our morning meso analysis. Again, that really straight hodographs. We had convection form off the mountains very early on in the afternoon. This loop goes around 2 to 2:30 p.m. local time. Cells were splitting. We had a pretty even atmosphere for left and right moving supercells. So what we had was an already, pretty early on, a budding hail threat. There was already a couple hail reports along our major Interstate 25 corridor and just east of there. We had a lot of splitting cells, a lot of wind, a lot of cell interactions, a lot of merging and colliding of these various splitting storms, which really just leads to, again, more of that hail, more of that wind, and it does work to diminish our threat of more organized mesocyclone formation and tornadogenesis. And so, what we're seeing is what we were expecting based on the morning, but as we know, if you're not paying attention, things can change very quickly. So this is a part of that be curious mindset where you can't just get tunnel vision on the storm that you're warning for. You have to keep an open mind about what the environment is doing and what the environment could be doing. Working with Ariel a lot, especially on radar, something he likes to always reiterate is, what is the radar going to look like in 1 to 3 hours? And this kind of situational awareness doesn't just come all at once. It's fairly complicated multitasking to be aware of everything going on at once, both within and outside of your own forecast area. Just the atmosphere doesn't care about boundaries, and neither should you when you're taking into account this bigger picture. And so, through a really good use of office and interagency teamwork, we're really able to really keep that bigger picture in the corner of our eye at all times. And this is a really great example. Prior to the start of this convective event overnight, we had some pretty widespread convection occurring in Kansas to our east, like was mentioned earlier. Well, that convection kicked some pretty moist outflow into the eastern part of our plains. And what that's going to do here going forward is that's really going to impact the low levels and the boundary layer. And you'll find very quickly that the atmosphere we were dealing with in the morning and even early afternoon, even to the start of this event, was not the atmosphere we were dealing with just a few short hours later. And that communication between us and people outside of the office is really what helps us stay aware and stay ahead of these things, so there are really no surprises.
This is Stephen Rodriguez at Pueblo. Thanks, Mikey G. There. It's kind of been, touched on, several times, kind of monitoring these environmental changes, monitoring, or at least trying to stay ahead of the environment, anticipate what might transpire. Klint and then Harry and Mikey D kind of touched on varying aspects of our approach within Pueblo. There, staying in tune with the mesoscale details, following the science to then, actively and appropriately message that to our partners, utilizing that ready, set, go concept that then has transitioned into just that continuous flow of information, downscaling that information, refining it so we can then provide as much heads up support to our partners there. So there's many key aspects of it that easily could be focused on either science and service there. But once again, everybody's kind of been alluding to, the curiosity, having an open-mindedness there to it. And that's kind of almost another piece to the puzzle when we're talking about addressing high-impact, low-confidence events, that be curious mindset. Mikey G just alluded to that, you're trying to anticipate, or at least trying to, negate the possibility of surprises, but by staying in tune with the mesoscale details, continuously messaging our partners and having this be curious, open-minded mindset, you can kind of help to try to mitigate those potential surprises. And then this is really helpful when we're talking about those high-impact, low-confidence events. Harry mentioned we were anticipating the possibility of a tornadic development. It wasn't, quite obvious in the morning. We were still had that in our radar per se, if you want to call it that. We were messaging that there, but it may not have been at a direct focus, or at least what we were expecting for the later part of the day. So having this be curious mindset, open for other possible scenarios, and continuing to ask questions really kind of helps us to kind of we stay ahead of the game and try to help, once again, not have these surprises as per se. Additional, scenarios or events that we encounter here, once again, the highly evolving environments that we've seen in this with this high impact, low confidence event, but also just mesoscale driven regions here, as we really kind of see here across southern Colorado with our high terrain there. Next slide, please. And the benefits of curiosity, just a quick background on it, is actually, we attended actually, the Workplace Violence Prevention and Response Office monthly webinar earlier this year, and it was actually on maintaining healthy relationships with effective communications. One piece of that presentation that they spoke to were benefits of curiosity and how that can, impact not just individuals but teams. And so when we're talking about benefits of curiosity, we're talking about, once again, always be curious, having an open mind, and asking questions. What could happen down, in the future? Mikey G spoke to what would the radar look like in 1 to 3 hours. Asking these questions, what are the possible scenarios that could occur? Are there any worst case scenarios that that we are maybe not focusing on, that if they would occur, could potentially have some high impacts, even if they're of low confidence at that point there. And then having that mindset, additional questions, if that were to occur, how could we message that? How could we stay ahead of the environment and provide the best service possible for our partners? And so we've actually been able to take the concept of the benefits of curiosity and directly apply that to operational meteorology within WFO Pueblo, where we're having an open mind, we're staying in tune to the environmental trends, in tune with the mesoscale details. By doing so, we're really kind of adding flexibility to our approach, and really kind of having more accurate diagnosis of the current setup, but also the future setup. So once again, what's the environment going to look at? How are we going to stay ahead of the environment? How are we going to stay ahead of the hazards to appropriately message that to our partners? By doing so, we're building confidence in the event and in those expected hazards by staying in tune with the details, having that open mind. That we're building confidence, and then it gets to a point where, okay, this might happen. We need to really focus on this. And then once again, by doing all of this, it really allowing for kind of unique approaches to benefit our partners, and then allowing in an extended time of warning per se for our partners outside of the traditional means, the tornado warning, the severe thunderstorm warning.
And Stephen, this is Harry again. I just want to reiterate here, this is not an easy task. I mean, this really does take a shift in the overall culture of how we're doing things, how we're able to feel comfortable to speak up when you're seeing something, to be able to say something. It's all great if this is, you're thinking all of this, but this actually has to be put into action. So, it definitely takes a shift in culture and really just being open to everybody's opinion and really building that comfort amongst your team.
That's exactly right. Working off of what Harry and Steven just said, this be curious mindset, it doesn't just apply to convection. It applies to really everything that we do. This concept really, got off the ground after we worked a very complex early morning winter event that had some traffic impacts. Now we're applying it to convection, flash flooding, wildfires, just messaging in general. And so now we're going to take this be curious mindset, we're really going to run with it in real time. So like we said before in the early analysis setup, we have great directional shear, good cape, a little bit of inhibition. We already have dominant motions for supercells being, splitters, even left and right mover dominance, a lot of storm interaction. So initially, like we said before, tornado threat was low, non-zero. And now what we're going to be seeing is a rapid, rather local to mesoscale shift in our low levels and in our boundary layer. From that convection, from the late overnight to early morning hours in Kansas, we had 60 dew point air being funneled from the east into our area, which is rather moist for the southeast plains over here. And so now what we get is, the low level boundary layer, which was being mechanically mixed by that 500 millibar speed max. We had a lot of diurnal heating. That mixing is gonna decrease available moisture and further work to shift things more to, like we said a couple times, hail and wind. However, with this 60 dew point air funneling in, boundary layers getting revitalized. We're getting sheltered from that diurnal heating and mixing. And this low level moisture is going to work to offset the stability of the boundary layer, because at this point, 23Z is 5 p.m. local time. The sun's going to set pretty soon. And as soon as the sun sets, mixing is going to cease. Our boundary layer is going to stabilize, and any convection we have left, more often than not, is just going to gust out, and that's going to be the end of it. But now what we're seeing is a very atypical boundary layer setup with this influx of new moisture. And so now those of us working the ops floor have to think, okay, the situation has changed. What could happen next?
So yeah, this is really just showing, kind of contextualizing the environment based on some of the mesoanalysis graphics around 0Z. So just like, as you can see, like Mike was saying, with that easterly increase in easterly low level flow that elongates the hodograph as a whole, now we're dealing with this even higher deep shear environment, 60, 65 knots of deep shear over the area. Also, you'll note that, just as Mike suggested, we're getting into that time of evening where we're going to get that nocturnal decoupling of the boundary layer, that onset of that nocturnal low-level jet. And what is that going to do to the hodograph? As you can see clearly there, we went from this generally straight hodograph to now we have this large clockwise turning hodograph, and especially in the low levels over the eastern plains, characterized by this, on the lower graphic there, that effective SRH nearing 500 meters squared per second squared. That's a high-end environment for established supercells moving into this area. So just thinking conceptually, through what the hodograph does to storm behavior, what this deeper shear environment, we're going to essentially see this change in mode from this splitting supercell mode to the more of this right dominant supercell mode. So we're essentially creating this localized corridor here that's going to be favorable for tornadoes. And we're going to show how we take this information, which we anticipated as a possible outcome, and how do we message this in real time.
And, using all of this mesoanalysis, but then also synthesizing, input from outside of our office. Again, we've kind of moved away from, being an island of a CWA and just welcoming all input. And, just looking at the people who are a part of this. Bill Line, he was a forecaster at Pub, And now he's helping out in different ways. You know, he's with Sierra now, and he's given us some satellite support, giving us, you know, some images of what had happened already. As you see, you look real close in there, that green, that's ice that fell from one of the supercells that have developed. Brian Berg from Topeka, I believe, you know, he was in the RMA that day, and we chatted, you know, pretty much nonstop throughout this event, talking about you know, the near the storm environment, then the storm scale decisions as well. And of course, here at the bottom, there's Harry. You know, thank you again, Harry, for the insight during that event, and also for the help and collaboration with this presentation. But you know, this is what the RMA is supposed to be. It's not just you know, you're your own CWA, you're your own island. We're opening it up to people who you know, want to help out with meso analysis and whatnot. So Brian Berg and Harry Weinman and Bill Line. But you know, this was it was a success. You know, the use of RMA was a success today on this day. It brought a lot of confidence when issuing warnings and mesographics. You know, we used direct, you know, feedback from Brian and Harry to create, you know, these mesographics, which I put in the chat just so they could see it as well. You know, this is it. You know, especially with SPC and Bill, this isn't just you know, a whole region concept. It's a whole agency concept. We are one NWS, right? So, anything to add on that? Okay, next slide then. And this continues. You know, it's not just going to be, you know, talking about before the thunderstorm or the tornado develops. At this point in time, like, okay, it's there. How long are we talking about? So it's just continued downscaled messaging. And you know, the one thing I really like to point out from Brian, and this is incredible, you know, the winds at Lamar back to 100 degrees with the remainder of southeastern Colorado closer to 160. Short range, RAP, and HER wind fields do not resolve this mesoscale backing. So, you know, the models that we're trying to follow to try and, you know, get an idea of what's going to happen in the future, you know, they're not always right, of course, as we all know. And so in this case, enhanced storm relative felicity is going to be incredibly high with this kind of environment. And that was pointed out by Brian. And you know, we talked about it. It was a continuous dialogue between, you know, the people in the RMA to me, then to the warning operators. It all just kind of fluidly worked. And you know, that continued with our meso analysis discussions. You know, at this point in time, this is 4:45 on June 7th. We are now highlighting the far eastern plains with increasing threat of tornadoes. We're explicitly talking about tornadoes in with strong verbiage. Of course, we're talking about the large hail and the winds. That's a given with these kind of supercells. But now we're talking about the increased threat of tornadoes. And this is not just our office looking at this and looking at the meso analysis, because we're doing that. We're staying curious, but we're also collaborating with our with everybody in the agency in this case. And notice the verbiage here. Now we've transitioned to confidence in storm development, high. Confidence in severe storms, medium high. This is how our continuous flow of information works. We get higher confidence throughout the event, and we're going to talk about it like that. Now, following that mesographic, we're talking about the SPC also. Of course, Harry was in the chat room with us, but the SPC issued an MD that day, and you know, specifically over primarily our southeastern plains there. And so, you know, the afternoon meso beta scale analysis showed the quick changing environment that we've been talking about. All of that has now then cultivated into this bottom left mesographic. Increased tornado risk over the next few hours. Now, this is one of our strongest verbiage of the day. You know, forecasters at the NWS and Pueblo are growing increasingly concerned for the shaded area. Please stay aware, monitor your NOAA weather radio, and keep an eye out for WIA warnings. You know, we have high certainty in our confidence discussion. Of course, under these supercells, 2-inch, 70-mile-an-hour winds, tornado risk increasing in all caps. All of these small things, are necessary for communicating, what we actually think. We send these mesographics out a lot. What's going to distinguish between a generic mesographic and then this? It's things that we say, right? And so with this, with the confidence from the whole agency in our office, this is the kind of graphic we're issuing now. Anything to add? Okay, next slide.
So now we have a couple different avenues of thought as we're now pretty deep, several hours into this event. With that be curious mindset, we've kept an eye on the mesoanalysis. We've seen the hodographs, bowing out. We've been talking with Klint, who's giving us the highlights of this RMA chat in real time. Experts from around the agency, far outside of our county state borders, all giving this expertise, this input. And now when the boundary layer gets modified and every supercell on radar suddenly just turns to the right, instead of being caught on the back foot and scrambling for polygons, the radar operators look at each other and nod and go, just like we thought. No surprises. So now we have this change in the vorticity field. We have this change in the shear profile. And like I just said, all those storms suddenly just turn to the right, and now we've completely changed our mindset well in advance of anything actually developing. We were looking at large hail and winds, that's still happening, but now we got to look at tornadoes. And we had this in the bag. It was a well-oiled machine, no surprises whatsoever, because of this really extensive network of communication, this be curious mindset we've been practicing, and a really healthy dose of agency-wide teamwork.
Okay, so good morning, everyone. My name is Paul Stewart, and I'll be going over the ProbTor, that's probability of tornadoes calculator results with you. So the ProbTor calculator is essentially, it's one more tool out of the quote-unquote storm interrogation toolbox, so to speak, that forecaster can use when deciding whether or not to warn on a storm with a tornado tag. So running the calculator, what we do is we put the storm scale attributes into it, along with some of the known environmental parameters. And we use this, so you ingest these numbers, and it calculates the probability of tornadoes basically occurring within the storm. So looking at the values here, you can see that we're actually above the mean distribution for tornado or tornadic events, rather. And you can see that actually the important thing about this is that the falsely detecting tornadoes is less than 10%. That's going to give the forecaster pretty high confidence. And especially given the environment with the increasing low-level SRH, it really helped to make that decision to know that there was more than likely a tornado occurring that would be on the lower end. It'd be either a high level EF0 or a low scale EF1 possibly occurring.
Yeah, that's great, Paul. Yeah, just one thing here. Sorry to cut in there. I just wanted to clarify that this is also, after the warning is issued in this case. So, as far as decision making to initially issue a warning, probably go ahead and use a lower probability, just so you're really maximizing that probability of detection. So the higher the probability that you're using, the lower detection rate. So you would essentially be using a lower probability for an initial issuance. But in this case, it's giving you high confidence that there is ongoing tornado potential with that storm.
And during these storm scale kind of decisions that we're making, we're also at this point, talking with our local partners. We are a weather enterprise. Everyone has their role. So while we're in warning operations, me, who is on the mesoanalysis desk, I was talking to our core partners. And this is something that, I think our office is really proud of. One of our local Mets, Brian Bledsoe, brilliant guy. He has such great things to add, and Robert Hahn as well. We were talking about the mesoanalysis with them, and they had, great input about this. But, these are just words on a slide, right? But it's much more than that. These are relationships that we're building with the weather enterprise. You know, if we have a great relationship with them, which we're working on continuously, there's going to be, you know, just, you know, the weather enterprise, somebody said it earlier, a well-oiled machine. Like, that's what we're going for. It's more relationships and, you know, getting their input. We might miss something as in our NWS centric kind of ways, and they might be looking at something, and boom, that's something we can add to our meso analysis. It's just another, you know, I guess, arrow in the quiver, if you will, you know, with these local broadcast partners.
Excellent. So yeah, this is a really successful just use of the meso analysis, the data, and really anticipating what updrafts are going to be doing and how you can use that information to tailor your polygons to provide a better service in your local area. So in this case, we had, you know, this tornadic supercell tracking toward Lamar, which is one of the higher population density cities out there. A purely linear extrapolation would suggest that Lamar had to be in that warning. But again, thinking back to that evolution of that hodograph and how storms are going to evolve, how we know that bowing of the hodograph is going to allow for these storms to really dive south, and we can use that information. And in this case, they were able to leave Lamar out of that tornado warning with pretty high confidence, knowing that that storm was going to dive south based on everything we've looked at.
Yeah, exactly right. This was not the only tornado of the evening. So why focus on this one specifically? Like Harry said, this is one of those crucial local scale decision points. Ariel and I were on. We made this warning, and through all this communication, you know, we really anticipated that right deviant motion of that supercell, thanks to all the information we've been working with as seen thus far in the presentation. And so what this ended up being was we avoided a pretty substantial false alarm for downtown Lamar. They had already seen some impacts the previous day from hail and some local street flooding. So getting a tornadic storm headed right over downtown would have been, you know, fairly devastating to the urban population there. But we were able to avoid, you know, that false alarm, that waste of resources, because we knew exactly what the environment was doing, thanks to all this collaboration. And lo and behold, not 10 minutes later, we go on Twitter and we see a picture on social media. There's a tornado in a field, like I believe it was 8 or 12 miles south of Lamar, hitting nothing. So, you know, what this results in is making those really crucial, very short fuse decisions with a lot more confidence. And as a result, our quality of service increased substantially that day, which was a fantastic feeling to have, because we were really able to help our partners and the public be much better informed.
Okay, so we were showing an earlier run of the prop tour calculator, and this is actually showing at a later time. So you can actually see that the simulated tornado probability increased from what was previously ran, and also the tornado wind speeds slightly increased as well. So there's definitely tightening the lower level of circulation. And again, this is, you know, giving higher confidence that, you know, there was likely either a high-end EF0 or a EF1 possibly occurring. So this is just showing this is still that same storm that was just moving south of Lamar. This is the eastern supercell, to clarify. And this one is actually showing the western supercell that was threatening Los Animas. Just looks like it just barely missed just the east of the town. But again, this calculator was ran, and it was determined. The important thing with this was that there was actually even a little bit of a higher probability of possibly an EF1 occurring with this, given the fact that the inbound-outbound winds, even though it was a wider distance between the two reported or the two analyzed inbound-outbound winds, it actually produced a higher possible tornado wind speed with this, you know, because it could be likely occurring stronger winds within that. being it was a further distance between, so there's likelihood that it could be a tighter circulation and stronger winds occurring within it. So again, this definitely gave WFO Pueblo higher confidence that there's possibly a tornado occurring with this storm. And this is actually showing, this was sent in by Spencer Dan. It was actually showing that tornado that was. Yep, it was taken just by. All right.
Yeah, so reaching the end of our presentation here, but just as an overview, this is the same image from our second slide, but that's what the supercell looked like. We saw what the tornado looked like on the ground, and this is what the local storm reports look like. You know, there's the tornado reports going down, and then even continued a little bit further down into Tobacco County there.
So just as we all discussed here, we know the outcome. This was a rare event overall for the Pueblo CWA. You can see that on the chart here on the bottom. It's pretty rare to have an event with more than 3 to 5 tornadoes in a day. I mean, you know, from 1995 to 2021, there's only been, you know, 5 days with 4 tornadoes in a single day. So in order to really capture an event like this and not let it sneak up on you, we need to work as a team. We all need to be paying attention, talking, and just keeping that curious mindset. Otherwise, you know, these events really can sneak up in you. That's the whole idea with these rare events, is they're rare, so they're hard to really get ahead of. So it just really speaks to, you know, how you do this. That's the only way.
And as you know, Harry mentioned there, you know, the high-end event that occurred on June 7th with multiple tornadoes there. You know, with this, given this type of event, you know, at least from our perspective, you know, there are definitely many successes for WFO Pueblo with proactive anticipation and messaging, and also with our warnings, especially when we're talking about that rapidly and evolving environment that then led to tornadic supercells across southeastern plains there. But with that, we wouldn't be trying to make ourselves better, our office better for our partners without kind of looking inward. And that's what we kind of did with this presentation, a kind of a team approach to look back at the event and where there were some room for growth and opportunities to improve upon our services, and as well as the science that led to those services there. And obviously, given an event like this, we want to try to provide more lead time, at least as much lead time on an event or a day that could lend itself to having multiple tornadic supercells there. But excuse me, highlighting just the overall team aspects of it that Klint really kind of focused in on there. The going from a whole office to a whole region to a whole agency-wide concept was pretty remarkable in our eyes, and we're really kind of focusing that team approach within the office, but then taking that with the RMA, and then likewise with the wonderful support from Haley at SBC, all the great work they're doing there, that all comes together and culminates to provide the best service possible. Additional key aspects, once again, that strong team approach, and even after the event, once again, this presentation, highly impressed with our office coming together to provide, this event for you all here on this day here. The storm scale decision making, but also the be curious mindset. Next slide, Klint. And then just lastly here, that concept, we're taking the benefits of curiosity and applying that to operational meteorology, where we're asking the right questions, that then having that open mind to other possible scenarios that ultimately helps us in Southern Colorado move from a high impact, low confidence event to a high impact, higher confidence event, to where we can provide the best service possible for our public and our partners. Ultimately, this approach then supports a strong team environment where all thoughts and ideas are valued, and Harry hit on that multiple times there. And then additionally, too, it's going to set up our office, it's going to set up our team to work together to continue to build upon our successes and to try to improve upon what we are doing for the next big event there. And so that, I believe, is our last slide, Clint, right? Yep.
Yeah.
All right, guys. Well, that was a fantastic presentation. Great teamwork involved to put this all together and do a really seamless presentation. At this time, we'll go ahead and entertain any questions if you want to raise your electronic hand or enter that into the control panel. And I'll wait for a few hands to pop up.